All right, so this section is solving using the elimination or combination method. You'll hear it used either way, but I use elimination. So we use this when we are in standard form with both of our equations, meaning the x and the y are on the same side of the equation. They equal a constant. So these are your steps to go through if we have to do manipulations to the problems. But we're going to start with step 2 for today on this, since we're just introducing it. Step 1, where we multiply one or both the equations, so that one variable term will cancel out with the other. I'll save for another video, but we'll go through it, but the notes are here as well. So think of this as part 1 of this lesson. So looking at example 1, you can see that we have two equations. So this is still a linear system in standard form. All right, and my x's are lined up, my y's are lined up, and my numbers, my constants are lined up. So we're starting with step 2, where we combine the terms of the system. We always want to make it, or we want to see that two of these terms will combine to equal 0. What that does is it gives us only one term or one variable to solve for. So if you can see in this, -6 and a +6, and they're both y's, will combine to equal 0. So step 1 is making it sure that these do have one thing or one term, variable terms that are opposite of one another. 5 and 3x are not opposites, but a -6y and a +6y are. So down here we just add them all together, like old school math, line it up and add them. So 5 plus 3 is 8x, -6y and +6y is 0, so that just goes away. And -32 and 48 is 16. Once we have that, we rewrite our problem to 8x equals 16, and it's a one step. Divide by 8, we get x equals 2. Once we get this, so I mean that first part in this method is very nice because it's pretty straightforward. They combine. It's a one-step problem after you use your calculator to add these together, and you get your answer for x. So what we do next is we have to use our original equations, and we substitute this 2 into either this x or this x. So as you're reading these notes for reference, you can see that I use both of them. You only need to use one, but this is showing you that they both work. So if I substitute an x for this, I get 6 plus 6y, subtract the 6 from both sides, 48 minus 6 is 42, divide by 6, you get 7. But if I use this one, 5 times 2 is 10, minus 6y, you bring everything down. Subtract 10 from both sides, -32 minus 10 is -42. You divide by -6, and you get 7. Okay, so our ordered pair, you can see here, is an x equals 2, a y equals 7, so that's how I can write it in that ordered pair of 2, 7. All right, so again, I'm going to do another video which talks about how to manipulate one when we don't have terms that cancel out. You can see that there's no opposites here. So it's a little more involved, but for right now, we're going to practice with these two problems. So these are starting with step 2. Now, it doesn't matter which ones cancel out, whether you cancel out your x's first and then solve for y second, or whether you cancel out your y's first and solve for x second. Sometimes it's just a matter of how the problem is set up. So when we look at this first problem, like right away, we're looking for opposites with our variable terms. I have a 1x and a 3x. I have a 2y and a -2y. So right there, that tells me these are going to cancel out. So now I'm going to add these. Remember, this is a 1x. 1x plus 3x is 4x. These become 0. Bring down my equal sign. And 7 minus 3 is 4. So now I can divide both sides by 4. That gives me x equals 1. So there's my x value. Now I have to pick one of the two, let me erase that, one of the two equations. I can either pick this equation or that equation. I'm going to pick the first equation because it looks a little neater. It doesn't have a negative. It's got the x by itself. So what I'm going to do is I'm going to take this 1 and put it in for this x, and I'm going to solve now for the y. So I do 1 plus 2y equals 7. So that 1 is that x, which is this x in that problem. So now we can subtract 1 from each side because we're trying to solve for y. So subtract 1, and I get 2y equals 7 minus 1 is 6. I divide by 2, and I get y equals 3. So my ordered pair, the solution to these would be 1, 3. All right, so this one over here is the same type of problem. You know, if you're doing this on your own, pause this and try it, give it a shot. And if not, here we go. So I can see that my x's here are opposite. So those are going to combine to equal 0. Now I combine my like terms of my y's. So I have y plus y, so that's 2y equals 3 plus 1 is 4. Now I'm just solving this one-step equation. Divide by 2, y equals 2. So there's my y. Now I have to solve for x, right? So I'm going to take this y and either substitute it in for the first one or the second one. It doesn't matter which one you pick. You know, you'll get the same answer for x either way. But so I'm going to substitute it in for the second one. So I'm going to write my second equation, 2x plus my y, which is 2. So I substitute that in there, equals 3. That's right there. So now I'm going to subtract 2x from both sides, or minus 2 from both sides, sorry. All right, so I combine those, then I get 2x equals 3 minus 2 is 1. These 2's combined equal 0. So now I have to divide. I'm dividing by 2 to get x by itself. And I get x equals, and I can leave this as 0.5 or 1/2. So I can call it 0.5. That's okay. So there's my x, there's my y. So my ordered pair was 0.5, 2. All right, now as always, you're trying to solve these algebraically, so we could use our graphing calculator and plug these in to see if we are correct. So let's go ahead and do that. All right, so I went ahead and brought up our graphing calculator, so let's go ahead and try with this one. So I'm going to do x plus 2y, and that equals 7. So there's that line. And then my other line will be 3x minus 2y equals -3. And I look at where they intersect, and you have 1, 3. So that's good. So that checks out. Let's try the second one. Again, I would encourage doing this just to double check your math at all times. So we have 2x plus y equals 3. And then we have -2x plus y equals 1. What's nice about this is you don't have to put it in slope-intercept form when we're doing decimals. It's easier to graph that way. We look at where they intercept, 0.5 and 2, so that checks out.